Alright, we're back. So I'm going to use thrust washers here as my measuring device. So I can take the tang right here and stick it in there, and the washer itself, and get the dimension I need. Okay, so we have the original stack. So we got the original bad gears. So you go like that, dog to dog. Correct direction helps. Okay, so you sit on top of the dog that way, and on top of the dog that way, and you got a gap right here. Oop. Right here, you can put a washer in there and get it. So all the dogs are stacked up. So my clearance between all my dogs is only this much clearance, which is not much. So this one here, looks like we're close to that number, but not quite. There you go. Between that one and this one. Okay, so this one here definitely fits in there. Too high. What's this camera so low? I can't see anything. Okay, so that fits right in there like that. It's got a little thou or so clearance. The other one's tight. So the dogs are all stacked on top of each other. So our whole window for clearance is the thickness of this washer here, which is 50 thousandths. Okay, so now we take the new parts. So we get our new gear. The other new gear. That's tight. That's supposed to be a slip fit. Not quite a slip fit. These parts are not happy with each other. That might be a problem. Yeah, pretty sure that's going to be a problem. Slide hammer. So when this was cut, it's got burrs in here. All these burrs have to be unburred. Great. I'm going to take a used one here that's already worn. So this one obviously has no issue. Appears to be an Andrews problem. Yeah, appears to be an Andrews problem. They're a little bit too precision on their fitment of parts. Doesn't fit. That is going to be a big problem. Ah, don't get your finger stuck in that. That's going to make it hard to shift my bike when it's that tight. Yeah, that's not going to work. So you got clearance that way. So where's it tight at? Is it tight in the bottom or in the top? Because it's got clearance in the splines. We'll have to figure that out now. That's another thing we have to figure out. Okay, that goes in there. We got this one goes like this. Okay, so this one's going to go down until it touches. Not there though. The dogs touch. Okay. And you can see the massive gap right there, which I do not like. So we are going to be doing something about this problem. Okay, well it's more than this one, but it's close. Just like an 80. 75. There's our 25 number again. That 15 and 10 added together makes 25. Oh, it's 25 different. Okay, so if if I want to keep my shift pattern nice and tight, like I do, then we got to do something. So I like my gears just about touching it. See how much further I got to go before it shifts? When it's that close, that much gap in there. When it's a lot closer together, you don't have to move so far. But the other problem is the gear doesn't fit. That's a whole nother problem. So these parts are not happy with each other. It looks like I'm seeing rub marks right across the tops of these faces here. So that must be the tight spot. Okay, we got another shaft. Maybe it's better. Solid. Solid shaft means it works. First test, does this fit on there without binding? Failure. Nope. That would be a failed test. Easy test. Do our measurement here. 28. 25. It's not enough to worry about. 3,000, not worth the headache. Okay, so appears we're going to have some issues. See, we're trying to make a job easy, and it's not cooperating. Typical race bike, pain in the ass. So we got two issues. This is too long, that's too fat, and that's too tight. There you go. How are we going to fix these problems? I think the easiest way to fix it is to cut the washer. Because this is a nice precision fit, and I don't really fill it in there. I don't really want to screw with that. Having this go deeper in there is not going to make a bit of difference. It's actually giving me more support on the shaft. It actually makes it stronger. So I'm good with that. Now, it'd be nice if that washer had come out of there. Then I can just swap it out to the correct washer, the other one, but it didn't really want to come out. But we're going to have to cut that thing out of there. Alright. Fun, fun, fun. And then we have to make this fit nice and loose, because I want it to be nice and loose so it shifts real nice. The last thing I want to do is have a hard shifting bike. That is not good for a race bike. You want loosey-goosey so it shifts really good. Okay, so I'm going to have to cut this down and then put the chamfer on it. And fun, fun, fun. Yeah. Okay. That bit that was pissed off at me, guess what? It's going to get way more pissed off at me. Because now I got to cut a lot of material off. One advantage of that is this becomes shorter automatically. I already cut that side. That's why it was longer. It wasn't cut as deep. Okay, that comes out. This goes in. This unscrews a bunch. This goes back in, and I'm sure this bit is going to be destroyed by the time I'm done with this job. I can pretty well guarantee that's going to happen. Okay, how's my tangent angle? A little on the high side. And over here we are definitely on the high side. So I'm going to go a little bit that way and a little bit this way. Of course, now we tighten up, it changes a bunch. There we go. And neutral is slightly up, which we do not want to be. We actually want to be a little bit negative because this is really hard. Close to flat. Doesn't want to go down negative. On a different spot. Oh, that's way downhill now. Even I can see that much downhill. That's ridiculous. Here's my cylinders are moving over there. Yeah. It kind of wants to be neutral. There we go. Slightly downhill. About 5 degrees negative. Looks good on the center. This is too much this way. Get some negative in there also. Okay. All the numbers look good. So when you cut really hard material, you want to be negative, not positive. Positive is going to try to dig in like this. Negative is going to rub like this. More rubbing than cutting. So our top angle here is slightly downhill. We have back clearance this way, and we have clearance this way. So we got everything's got clearance. The bit is not chipped too bad yet, but it's going to be more pissed off at me before I'm done. Because I guarantee you with that interrupted cut that's in there, in the hard material, you ain't going to be happy. Guaranteed. There's our negative. Oh. Zero that out right there. We want to cut 25. Attempt to cut 25. We'll see what we actually get. And we're not accounting for chip wear, and who knows what we're going to be. That'll be a whole nother problem. Okay. Pass, let's see what happens. probably 7 more. Bit's moving. Not cutting at all. Appears to be very unhappy with what we're trying to do. Alright, try that again. We're not making much progress. It's going to take a lot more pressure and a lot more heat. It's going to definitely kill the bit. Without a doubt, it's going to kill the bit. Okay, let's see what we can do. Yeah. Not happy. Alright. I don't think it did much, but who knows? Did it cut 3 thou or did it cut 30 thou? I don't know. One way to find out. This is our go, no-go gauge. If it goes in, it's no-go. If it don't go in, it goes. appears that we ain't done nothing. Except lost a bit. That bit's destroyed. Let's see if we cut anything at all. Oh, we did cut something. Oh, more than I thought. With the gear move. No, we did cut something. Cut quite a bit. I'm shocked. I didn't think we cut anything. This is a 60 thou washer. Barely goes in. So we're close. We cut 15 out. I didn't think we cut squat. I am positively shocked that that's even cut anything really. Okay, did a better job than I thought I did. If I sacrifice a $50 cutter, I don't give a shit. That ain't no $50 cutter, that's about a $5 cutter. Cost you $10 in shipping to get it, but yeah, it's kind of not supposed to be radius like that on the tip. So anyway, it's cutting it. It ain't happy, but it's cutting it. So I'll cut it some more. You need another 10 more out of it. The downlink here was showing 30, so I didn't know if something was moving or it was actually cutting metal. I didn't think it was cutting more than about 5,000, so I was shocked. It's all right. I like being shocked. And I need another 10 more. See if we can get 10 more out of it. Wash is pressed in pretty good. That's some heavy cutting I'm doing. Okay, let's see what we got. Ew. Feels very gritty in there. Appears to be grit in the bearing surface. Not sure how that happened. What do you think? Somebody was cutting near it. Rough. Okay. That one's loose. That one's tight. Way tight. 60 down. 55. 55 is tight, so it's like 54. So we're a 50 number. Close. Now what I don't know is if I'm hitting on my radius or not, so I need to figure that out. mark up our gear like before, or shaft I should say. Like all the grit in there, but pretty rough. Just hitting on the outside of the splines where you want to be at. So that's good. Very uneven in there, so I'm going to try a little lapping compound on that, which I don't really want to do, but need to do something. Lapping compound. Nasty stuff. Don't want it anywhere near your bearings, so we're putting it right next to our bearings. Don't put it on your shaft, just on the tips here. If it gets in the bearings, it's not going to be good. You just put it there on the shaft a little bit. Find a dirty rag to use for wiping purposes. Found one. Make sure you wipe it all off the shaft where it's anywhere near the bearing surface, which is what I'm doing right now. Wipe it on my clean pants. That's a good place for it. Alright, let me lap it a little bit. A lot smoother now. Battery